Hello, and welcome to part 2 of Update 0. So in this update, I just wanted to show you what it's looking like as I start to flesh out the Air compiler backend that loads up a dynamically linked .so file. So the first thing is to look at this, which is a slightly more fleshed out version of air.zig, which we looked at last time. And the important thing is we have this struct for the dynamically linked library, which has an init. And this init only needs to be run one time. And because the Zig compiler is multi-threaded, we need to guard the init with a bunch of atomic loads and a mutex. So basically, one of the components of this DLL struct is this loaded Boolean right here. And we check to see that. And if it has already been loaded, then we know all the loading stuff has occurred. If it doesn't exist, then we have to go through a mutex. And inside the mutex, we do our DLL opening. We're going to start populating functions from the dynamically linked library. In this case, we're just going to have one function called generate, and there will be more functions coming soon. And then once that's done, we release the stored Boolean to be true, allowing future calls to just skip through. Of course, we also have to have a second one, because if one of the other threads that's attempting to initialize does block on the lock, then we need to triple check to make sure that the loaded Boolean hasn't been set to true. So now let's look at the generate function, and this is comparatively simple. All we do is every time we generate a function, we attempt to initialize the global DLL struct. And if that's possible, if that's necessary, then we go through it. And if it's not, we either block, or if the atomic Boolean has been set, then we can go straight through. And then what we do is we call the generate function, which has been populated here. And as you can see, generate has this function pointer type associated with it. So, second thing that I had to get changed in the Zig fork itself was this thing called a compiler API. And basically, I had to create a module in the build.zig that effectively exports these compiler internals for external libraries. And this may or may not get bigger as we go along. You'll see how that works in the CLR code. So in CLR, the build.zig creates an import called compiler, which is a module that imports those exported compiler ZCU code modules. In particular, we care about ZCU, air, and intern pool. Again, this may wind up increasing in its scope if necessary. One interesting thing is that there's some weird thread local stuff that isn't quite getting initialized correctly when we build the Zig compiler in debug mode. I believe that will go away if we build it in release. But since I'm just kind of optimizing for quick compiles, I decided to just go ahead and build this debug print that can only print strings. We don't have access to std.debug.print. I'm not quite sure why the initialization isn't happening when we do the when we attempt to dynamically load libraries in. And here's the exported generate function. We have to coerce all of our pointers into these any opaque C pointers here. The function index is a enum, which is of the intern pool. So we can pass that as a U32. But for all the other things, we need to recast the pointer coming back and forth between the C ABI and the Zig ABI. The good news is that as long as we compile the CLR, CLR library in the same way as we compile the Zig compiler itself, it seems like all of these structs will be safe to use. I may find that that is not the case later, in which case this task will be much more difficult. But this seems to work. And so then we just pass that to this generate impl function, which is actually able to be written in the Zig call convention. And here you can see all I'm going to do is I'm going to do exactly what I had before, which is to grab the intern pool off the Zig compiler unit, to grab the function index grab the function info from the function index, and then also get the nav information. The nav contains the fully qualified domain name or fully qualified name, and then we can take that and turn that into a string, and then just debug print what's going on. So I normally run this as test.sh. So, okay, so here's what we're going to do. We're going to use the compiled Zig file that exists in the Git submodule, and then we're going to pass the libclr that got generated here, and we also have to pass ofmt equals error, and then we're going to pass the file that we're going to build. And as you can see, we're getting these received functions, blah blah blah. These are all the functions that are being compiled by the compiler, and they are indeed being output by this shared library inside the compiler itself. So this is a great first step. I probably have to hook up a few more functions, like for example an init function and maybe like a mirror function, a set of mirror functions, and then also the link function. But once all those are done, we should be ready to start analyzing AIR for memory safety issues. All right. So if you like this material, if you like what I'm doing, please share and subscribe to the channel. And if you really like what I'm doing, there will be a sponsorship link down below. Thank you.